You are surely familiar with the International Space Station, ISS, which orbits Earth. This station is a collaborative project involving the United States, Russia, Europe, Japan, and Canada. Construction of the ISS began in 1998, with new modules continuously being added over time, eventually making it one of the largest human-made objects in space. Up to 6 people can stay aboard the station at once, though the crew composition changes regularly. Astronauts travel to the station via the Russian Soyuz spacecraft, and until 2011, they could also use the American Space Shuttle, which unfortunately no longer operates. The ISS orbits approximately 400 kilometers above sea level, circling the planet once every 90 minutes. This means that astronauts aboard experience 16 sunrises and sunsets in a single 24-hour period. But many may not know that long before the International Space Station existed, there was another space station orbiting Earth, this one belonging to the Soviet Union. It was called Mir, which translates from Russian as peace. Construction of Mir began in 1986 during the height of the Cold War and the so-called space race between the United States and the Soviet Union. Mir wasn't just a technological symbol of Soviet progress, it also demonstrated how determined the country was to compete with the US in space exploration. Mir set several records and conducted important scientific experiments. For example, cosmonaut Valery Polyakov spent 437 days and 18 hours aboard Mir, a record for the longest continuous stay in space at the time. Over its 15-year lifespan, humans occupied the station for about 12.5 years. Daily life aboard Mir followed a strict schedule. The day began with wake-up at 8 a.m., followed by 2 hours dedicated to personal hygiene and breakfast. Work started at 10 a.m. and continued until lunchtime, with breaks for exercise and meals. After lunch, work resumed for another 3 hours, followed by more exercise. Dinner was served around 7 p.m., after which astronauts had free time to relax or pursue personal interests. Mir was an advanced station for its time, contributing significantly to modern space missions. Key features included electricity generated through solar panels, water recycling systems that processed and reused waste fluids from the crew, oxygen systems designed to operate autonomously but requiring regular maintenance and replenishment, an atmosphere similar to Earth's, which was safer than earlier pure oxygen environments used in some spacecraft. This reduced the risk of fire, which could spread rapidly in a pure oxygen environment and potentially endanger the entire crew. International cooperation. After the dissolution of the Soviet Union, Russia continued to use Mir as a platform, offering its facilities to other countries, including the United States, France, and others. Mir even docked with American space shuttles, a symbolic step toward international cooperation in space. However, financial difficulties and aging technology eventually led to the decision to decommission Mir. Budget constraints and increasing technical issues forced Russia to reconsider plans for adding new modules to the station. Mir was not without its share of problems and accidents. For instance, in 1997, the Spectre module was struck by a Progress cargo spacecraft, damaging critical solar panels that provided most of the station's power. Also in 1997, a fire broke out aboard the station, lasting approximately 90 seconds and filling the cabin with toxic smoke. This situation was particularly dangerous because, unlike on Earth, you can't simply open a window to clear the air in space. These incidents highlighted the station's age and infrastructure wear and tear, suggesting that Mir might not survive much longer in orbit. Russia announced that due to budgetary limitations, Mir would be deorbited and burned up in Earth's atmosphere. Interestingly, just before its decommissioning, several private companies expressed interest in repurposing the station, including proposals to convert it into a television studio. In 2001, Mir's journey came to an end through a carefully planned 3-phase deorbiting process. In the first phase, the station was allowed to naturally descend to an altitude of about 220 kilometers. During the second and third phases, the station's own engines were used to guide it into a controlled descent, ensuring it re-entered Earth's atmosphere over the South Pacific Ocean. Most fragments disintegrated upon re-entry, though some debris likely landed in the ocean. The Mir space station stands as one of humanity's greatest achievements in space exploration, a testament to human ingenuity, perseverance, and ambition. Though it was conceived during the height of the Cold War, Mir transcended political boundaries and became a symbol of cooperation, resilience, and scientific progress. Its story is not just about the technological advancements it brought but also about the challenges it overcame and the lessons it taught us. Mir was more than just a laboratory in orbit, it was a home for astronauts from around the world, a place where people lived and worked together despite cultural and linguistic differences. It proved that long-duration stays in space were possible, paving the way for future missions and the development of the International Space Station, ISS. The knowledge gained from Mir's operations, including its successes and failures, has been invaluable in shaping modern space programs. One of the most significant contributions of Mir was its role in teaching us how to manage the complexities of life in space. From recycling water and generating oxygen to dealing with emergencies like fires and collisions, Mir provided critical insights into sustaining human life beyond Earth. These lessons are still applied today on the ISS and will undoubtedly inform future deep space missions, such as those to the Moon and Mars. However, Mir also highlighted the challenges of maintaining complex systems in the harsh environment of space. Over time, the station suffered wear and tear, experiencing numerous technical issues and accidents. While these problems ultimately led to its decommissioning, they underscored the importance of robust engineering, rigorous testing, and continuous maintenance in space exploration. They also emphasized the need for international collaboration to share resources and expertise, setting the stage for the cooperative spirit seen in the ISS project.